Hello everyone. So in this video, we will learn about the probability. Probability means possibility. So it is a branch of mathematics that deals with the occurrence of a random event. So when you are learning about the probability, you will come across the few terms which we will use frequently. So first we will learn what are the meanings of those terms, and then we will learn more about the probability. The first thing is experiment. So experiment is a planned operation which is carried out under controlled conditions. So for example, you are tossing a coin or you are throwing a dice. So these are the experiments. Now, in that experiment, suppose you are throwing a dice, so getting an head can be an event. So getting a particular outcome is an event of that experiment. So if you want to find how many heads, if you are tossing two coins, what is the probability of getting two heads? So that is the event of the experiment, and the experiment is tossing two coins, right? Or if you are calculating, or if you are finding what is the probability of getting two tails. So getting a two tail is an event, whereas tossing two coins is an experiment. Now, sample space is the combination of all possible outcomes. So when you toss one coin, so the all possible outcomes is either you will get head or you will get tail. If you're tossing a die or throwing a die, you have the possibility either you will get one or two or three or four, five, and six, right? So your sample space will be 1, 2, 3, 4, 5, 6. Now, if you're throwing two coins, so through two coins, so then you will have the possibility that either you will get head in both, or you will get tail in both, or you will get first head and then tail, second one tail, and or you will get first one tail and the second one head, right? So these are the total possibilities, and that is the all the elements of the sample space. So sample space contains all possible outcomes of any experiment. Now, if you have to find the event, so event can be anything. So for example, for tossing two coins, event A can be getting at most one head. So getting at most one head. So what is that meaning of at most? So here, if you So getting at most one head. So this word which we will get frequently. So at most. So at most means maximum. Maximum one head. Maximum one head means either you can get zero head or one head or two heads, right? So zero head means both the times you will get tail. One head means you will get either at most this is one head, so either 0 or 1. So for one head it is your head and tail, or tail and head, right? So these are the only possibilities what you will get. So the event A will be combination of these three outcomes. Now, second one, getting two different facing. So two different facing, so tail head on a head tail, getting two similar facing head head and tail tail, right? And if I write event T as get at least one head or one tail, maybe one tail or one head. So what will be the D value? So at least means minimum. Minimum one tail it should be. So minimum one tail means either there will be one or 2 maximum. There cannot be more than 2 tail because we are throwing the coin only twice. So 1 tail means it will be tail, head, or head, tail. This is, and 2 tail means tail, tail, right? So this is your event D. Now, probability, if you have to calculate, so probability is given by number of outcomes of that event divided by sample space. Now, if we consider the same example here, we know that the sample space for this one is your, if you see here, one second. So sample space here is 4, right? There are 4 possible outcomes, 1, 2, 3, 4. And probability is given by number of possible outcomes for that event and divided by total number of outcomes, that is number of total outcomes in the whole sample space. So it is for event A, it will be number of outcomes. So probability of A, I can change the color here. So the probability of A will be equal to a number of outcomes of that event, which is 1, 2, 3. So 3. And total number of outcomes is 4 because we have seen in the previous slide that sample space contains 4 elements. So 3 over 4. Same way, probability of happening of the event B is 2 over 4. So 2 over 4, which is half. Probability of happening of event C is 2 over 4, which is, this is 2, number of outcomes in that event divided by total number of outcome, which is 4. And probability of D is your 3 over 4. Right? So we can calculate the probability by calculating the number of outcomes for that event divided by total number of outcomes, that is number of outcomes in the whole sample space. So we can see the definition of probability here. So number of outcomes favorable to A and divided by total number of outcomes for that particular experiment. Now, if for any probability, for any event, the probability of that event will be always between 0 and 1. It will not be less than 0. That means it cannot be negative. It cannot be more than 1. So maximum it can be 1. So if it is 1, it is called as a sure event. That is 100% chances of happening of an event. And if it is 0, so then that is an impossible event, which is 0% chances of happening of that event. So the example of impossible event is, for example, if you're throwing a die, getting a 7 in that die, because there is no 7 in that one. So that is your 0% chances. And getting any number between 1 to 6 is a sure event. Also, if you're throwing a two-headed coin, so getting a tail is an impossible event, and getting a head, if you're throwing a two-headed coin, so getting a head is an sure event, because if you throw anyway, you will get a head. So that is a sure event, 100%. Probability of sample space is always equal to 1. Why? Because number of favorable outcomes, so number of total outcomes in sample space is 4 divided by total number of outcomes, which is again 4 for the previous example. So therefore it is equal to 1. So probability of sample space is always equal to 1. So here is another example for that one, calculating the probability. So find the probability of obtaining an even number in one roll of a die. So there are, you roll a die and you know that there are 6 possible outcomes. So sample space will contain these 6 numbers, 1, 2, 3, 4, 5, 6. And getting an even number, so probability of an event A is getting 2, 4, 6. So these 3 numbers. So 3 outcomes for that event, and total number of outcomes in a sample space is 6. So 3 over 6, which is 0.5. Now, if an experiment is repeated n times and an event A is observed f times, then according to the relative frequency concept of probability, we calculate the probability of that event as frequency divided by number of times it's repeated. Right? So if it is repeated, like suppose 2000 times, 3000 times, you cannot calculate if you are not using a formula. So it is number of times you observe that happened and divided by total number of times it is repeated. So that is the probability of happening of that event. So for example, 10 of the 500 randomly selected cars manufactured at a certain auto factory are found to be defective. As now here you have to find, assuming that the defective cars are manufactured randomly, what is the probability that the next car manufactured at this auto factory is defective? So you have to find the probability of defective car, right? So the car manufactured is 500 randomly selected cars, that is 500 times it is repeated, and they found that 10 are defective. So they found that out of 500, 10 are defective. So that is the observed frequency. So 10 out of 500, so we can see that probability is just 2%. So 2% or 2% of the manufactured auto factory will be defective. 2% chances that the next car manufactured at this auto factory will be defective. Now, a few relations we will understand here. The union of the two events. So union of the two events A and B. So then that means it will be either in A or in B or in both, right? So the term or is here. So why I'm pressing on that term, because that will be frequently. So whenever you have this term or, so you have to use union. So either it will be present on A or in B or in both. So then it is your A union B, and the symbol is this A union B. Intersection. So when the outcome is present in A as well as in B. So A and B. So if the word and is used, then it is your intersection, and the symbol for this is inverted U. So A intersection B if any outcome is present in A and in B. Complement of A. So the element which is not present in A, or the outcome which is not present in A, it is called complement of A, and it is noted by A dash. It is also denoted by A complement, not A, not A. So all these are notations. Different book you will see different notations. Now, this is a formula to calculate the PA dash or PA. So you know that total sample space. So this is the whole sample space, and probability of the whole sample space is equal to 1. So probability of sample space, it contains two events. So probability of A plus probability of A dash, which is present in A and which is not present in A. Total should be equal to 1, and hence, if 1 is given, you can find the other one by subtracting from 1. So PA dash is equal to 1 minus PA, or PA is equal to 1 minus PA dash. So here is an example. So frequently we will come across the problems related to cards whenever you are learning about the probability. So for your information, there are 52 cards in a deck, and out of 52, 26 are red, 26 are black. Now, out of the red cards, the 13 are hearts and 13 are diamonds. Out of the black, the 13 are spades and 13 are clubs. Now, what are these 13 cards? In each type is your A, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then J, Q, and K. So these are the 13 cards. Now, for this example, A is your red heart cards. And you know that red heart cards are 13 in number. So the probability of A is 13 out of 52. Now, how many will not be red heart cards? Now, if you are not using the formula, you know that out of 52, 13 are red heart cards. So remaining are not red heart cards. So 52 minus 13, which is 39, are not red heart cards. But using the formula also you can calculate. So PA dash is equal to 1 minus PA. So 1 PA is 13 over 52 and you will get 39 over 52, which is the same thing. Now for known problems, you can use logic and also calculate, but for unknown problems, you have to use the formula. So you have to know the both. Okay, so coming to the next section, here we will solve one problem here based on what we learned, that is union, intersection, and the complement. So roll a fair die if event B is getting an even number and event A is getting a number 1 or 2. So you need to find these probabilities, or you need to find the sets. First you need to find the sets and then hence the probability. So pause the video and think a little bit and then try to do it your own. So what can be, how you can get A union B, how you can get A intersection B, what is A and B first, what is your sample space, and then you can calculate what are these sets and then hence what are the probabilities. Okay, hopefully you got your answer correct. So rolling a fair die, so we will get the sample space here as fair. So I can write it here. So S is equal to 1 die. So we have a sample space of 1, 2, 3, 4, 5, 6. Right? Now A. What is A? Event A is getting a number 1 or 2. So we have outcome of either 1 or 2. And B is you're getting an even number. So even numbers are 2, 4, and 6. Right? Now A union B. So union B means which is present in A or in B or in both. So all the numbers which are presented here, but make sure it should not be repeated. So what are the numbers? 1, 2, 2 is already included. So 1, 2, 4, 6. So you got A union B as 1, 2, 4, 6. Right? A intersection B. So the number which is present in both. So which is present in both. So that means 2 is present in both. So therefore A intersection B is your 2. A dash, which is not present in A. So not in A, so 1, 2 is present in A, which is not present in A is 3, 4, 5, 6. Right? So A dash is 3, 4, 5, 6. B dash, which is not present in B. So B is your even number, so therefore B dash is your set of odd numbers. So 1, 3, 5. So 1, 3, 5. Now we have all this. So now what we have to calculate for A dash union B. So we have A dash and we have B. So union means either in A dash or in B, we have to include all. So 3, 4, 5, 6, and here 2. So you will get 2, 3, 4, 5, and 6, right? Intersection, which is present in both A dash intersection B dash. So 3 is present in both and 5 is present in both. So 3 and 5. Once you get all the sets, now you have to find the probabilities. So probabilities, that is probability of A union B. So probability of A union B, it is 4, and you know the sample space is 6. So 4 out of 6. So you get the sample space as 4 out of 6. Now, probability of A intersection B, so 1 out of 6. Probability of A dash, 4 out of 6. B dash, 3 out of 6. A dash union B, so we have 5 elements here, so 5 out of 6. A dash intersection B dash, so it is 2 out of 6, which is 1 over 3. Right, so this is how we calculate the probabilities of any event, given event. Now, the next concept is your conditional probability. So, conditional probability is the probability of any event given that the another event has already occurred. So, it is denoted by your this symbol, probability of A given B. So this symbol is not division, it is read as given B, A given B. So that means we are finding the probability of A, and where what is given is probability of B, already happened, right? So how we calculate, so we have this formula. So A given B, probability of A intersection B divided by probability of A, which is given, so that should be divided. And probability of B given A is probability of A intersection B over probability of A. So all these formulas will be there in the formula sheet. You no need to worry about remembering all these formulas. You have to just know how to use this formula to solve the problem. Okay, so here is an example for that one. So roll a fair die. Again, I have rolled a die once. What is the chance I got 3? So this is roll a die once. So that means total sample space is 6. And what is the chance that I got 3? So I have only 1 3. So probability of A will be 1 over 6, right? Now consider that I tell you that the number I got is odd. So the number I got is odd. What is the chance of getting 3 now? So if you know already the number is odd, so out of 6, odd numbers are only 3. So 1, 3, 5. And out of that, you need to find what is the probability of getting 3. So that means your probability will be 1 over 3. Right, so when conditional probability, when another event has already happened, so your sample space is reduced. So earlier you were not knowing that the number is odd, so you have the whole sample space. 6 numbers were there in the sample space, so you have to find 3, so it is 1 out of 6. But when it is told that the number is odd, when it is already happened, already that event is there, that the number is odd, so your sample space reduced from 1, 2, 3, 4, 5, 6 to 1, 3, and 5 to only odd numbers. And now you are selecting 3, so which is 1 out of 3. So that is using the logic, because this is your known problem, and we will see how to find or how to do it using the formula. So you have this one probability A is an event that is getting a number 3 if a die is rolled, and B is getting an odd number. So what is A? A is your only getting a number 3. So 3, and B is 1, 3, and 5. So probability of A is 1, and sample space, for throwing a die, it is 1, 2, 3, 4, 5, 6. So 6 possibilities. So probability of A is 1 out of 6. Probability of B is 3 out of 6, which is half. So probability of A intersection B. So A intersection B, this is 1. That is 3. Only 3 is common. So 1 out of 6. So probability of A given B is given by using this formula. So A intersection B divided by probability of B. So 1 over 6 divided by probability of B, that is 3 over 6, or 1 over 2. So it is your 1 over 3. So you are getting the same value using the formula as well. So you can use the logic when the problem is known. When the problem is an unknown, so you have to use the formula. Okay, so let's do a problem here. So you can pause the video and try to do your own to check your skills, what you learned till now. Okay, let's do it now. You spin a spinner with the 8 equally likely outcomes shown below. So what's the probability it landed on an even number, right? So 8 equally likely outcomes. So that means sample space is equal to 8, right? So probability it landed on an even number is even number. We need to find how many even numbers are there. 2, 8, 12, 6, and 10. So 1, 2, 3, 4, 5, right? So 5 are even numbers, so 5 over 8. Now your friend now tells you the spinner landed on an 1-digit number. So you already now know that the spinner landed on a 1-digit number. So 1 digit are which? 8, 7, 2, 5. So and 6. So 1, 2, 3, 4, 5 numbers. So your sample space reduced from 8 to this 5 numbers, and then you will find what is the probability that it landed on an even number. So out of this 5, how many are even numbers? You need to find. So the even numbers, so these are the 5 numbers, single digit numbers. This is your sample space. And out of that, what are the even numbers? So this is 8, 2, and 6. So your probability of A given B is, this is conditional probability because it's already given that that it's a 1-digit number. So, but we can use logic here because we have the data here, so we can find out how many are single digit. So which is 5, and out of that how many are even? So 3 out of 5. Right, so that is the probability. Now the last one, your friend tells you the spinner landed on a 2-digit number. So now you know that it's a 2-digit number. So it is 12, 15, and 10. So 3. Only 3 numbers are there. So what is the probability it landed on a number less than 12? Less than 12, so only one number. So this is only less than 12, right? So that is 1 over 3. So this is also conditional probability. So A given B, you already know that the numbers are a 2-digit number, and then you can find what is the probability that it landed on a number less than 12. Right. So now we learned all the relationships, that is union, intersection, complementary, and conditional. So now we will know more about when these relationships will be called as independent, mutually exclusive, mutually exhaustive, and complementary events. So two events A and B are said to be independent if the occurrence of one does not affect the probability of the occurrence of the other. So suppose you have 52 cards and you withdraw one card from there and you place it back. And then you are withdrawing the second time one card. So the second draw will not affect because the all 52 cards are intact. So therefore, the withdrawing the card from first time and withdrawing the card second time with replacement are independent events. Also, if you are tossing two coins, so tossing two coins and getting head in both the coins are independent event because getting a head in one coin will not affect the getting a head in another coin. Right, so for if the two events are independent events, then probability of A given B will be equal to probability of A. Whether B is given or not, it will not affect much. So probability of A given B is probability of A, and probability of B given A is probability of B. So probability of A intersection B, is equal to probability of A times probability of B. This is the formula which we use to calculate if the two events are independent events. Okay, yeah. Now, two events are said to be mutually exclusive if one of the two events occurs in an experiment, the others cannot occur. So that means the two are disjoint events and A intersection probability of A intersection B is equal to 0. So like if you are throwing a die and getting an even number and getting an odd number are mutually exclusive because getting an even number, so you will get 246, getting an odd number, you will get 135. So these two have no common elements. So therefore, no elements are in both in A and B, and hence the probability also is 0. Right, or the same another example again, if a coin is tossed, getting a head or and getting a tail are mutually exclusive events. Another is your mutually exhaustive. So two events are said to be mutually exhaustive if the probability of A union B is equal to 1. So probability of A union B, if the same example, if you see, so if you throw a die, A is probability of getting an even number and B is probability of getting an odd number. So A union B is your the whole set 1, 2, 3, 4, 5, 6. So probability of A union B is equal to 1 because it has 6 divided by sample space is also 6, which is equal to 1. So mutually exhaustive events, any example you can take where the probability of A union B is equal to 1, those events are called as mutually exhaustive events. And complementary events, if the any two events are mutually exclusive and mutually exhaustive, then these two events are complementary events. So the same example, getting an even number and getting an odd number from throwing a die. So getting an even number and odd number are mutually exclusive as well as mutually exhaustive. We observe that, and hence it is these are complementary events, and we know that these are complementary events. If you're getting an even, you will not get an odd. If you're getting an odd, you will not get an even. Right, and next is your Multiplication rule, which is the same rule as what you learned in independent events. If the two events are independent, then probability of A intersection B is equal to probability of A times probability of B. Addition rule. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Right? So, and if the two events are mutually exclusive, so mutually exclusive means A intersection B will be equal to 0. So therefore, probability of A union B is equal to probability of A plus probability of B. So here is an example. A hamburger chain found that 65% of all customers order French fries, 78% order soft drinks, and 55% order both. What is the probability that a customer will order at least one of these? So here, so 65% of the customers order French fries. So we can write the probability of ordering the French fries is equal to 0.65. Probability of ordering the soft drinks is equal to 0.78, and both, that is and, right? So probability of French fries and soft drinks is equal to 0.55. So at least means minimum one. So either French fries or soft drinks or both. So you have to find the probability of French fries union soft drinks. So you need to calculate that. So you will use the addition rule to calculate that, and probability of F plus probability of S minus probability of F intersection S, and you will get what is the probability. That is 88% of the customers will order at least one of these. A box contains 2 white balls, 4 yellow balls, and 5 red balls. A ball is selected from the box. What is the probability that the selected ball is red or yellow? So 2 white balls, 4 yellow balls, and 5 red balls. So red or yellow, that is union you have to find. So what you will calculate here is probability of red, that is 5 out of 11 balls. In total, there are 11 balls. So 5 out of 11, probability of yellow, 4 out of 11, and red and yellow. So no balls are of both the colors, red and yellow. So there are no balls which are of both colors, so therefore 0, and hence it is 9/11. Okay, so yeah, so you can practice more and more questions related to this from the textbook. And thank you.